Hello, ladies and gentlemen. This is the presentation from Group 11 at Applied Data Science 2024 on topic of collaborative filtering algorithm implementation and evaluation. So this presentation would be in 4 parts, which are introduction, implementation, training, evaluation, comparison, and conclusion. So we go to first part. Well, basically, we used a factorized rating model, and then we optimized it with stochastic gradient descent, and we added 2 regularization terms, which are penalty of magnitudes and bias and intercepts. And then we compared between the 2 post-processing methods, which are k-nearest neighbors and kernel ridge regression. Now, let's go to the implementation part. Well, first part, we use the stochastic gradient descent for optimization. We basically optimized the equation to the objective function with SGZ, and that gave us 2 matrices, P and Q, of which the product is the rating matrix. And then we used 2 regularization terms. Well, the first term is penalty of magnitudes, and that basically prevents matrices P and Q from exploding. So that protects our algorithm from overfitting to the training set. And the second one is bias and intercepts. That basically took into account the effects of users and items themselves. So we did that by adding biases to objective function. So the third part is cross-validation. We basically used a 5-fold cross-validation over those hyperparameters. For the original algorithm without post-processing methods, we used this cross-validation, as you can see, and the final answer is lambda equal to 5, f equal to 10. And then it's the same thing for the post-processing cross-validation. We finally took the k for KNN as 10, and we took RBF kernel for kernel ridge regression, and the alpha of it is 1. So we come to the part 3, evaluation comparison. Well, basically there is the trade-off between KN and KRR, because KN has a lower running time, which means a lower running cost, and a higher MSE. In the opposite, KRR has a lower MSE but a higher running cost. So here's our conclusion. Well, first, we can look at the MSE of the original algorithm, which is higher than both of the 2 post-processed version. So I guess that's something about post-processing. It's meaningful. And between 2 post-processing methods, there is a trade-off between MSE and running cost. So I guess that's all for my presentation, and thank you very much for your listening. Goodbye.